Converging lens, we know that for a converging lens, if light rays come in parallel, they converge and they meet at the focal point. Okay. Right. And that's effectively how a camera works, and that's effectively how the eye works. Okay, so you have a screen at the back here, which is called our retina. And you don't need, if you're doing biology, you don't need all the parts of the eye. We just need the optical features of the eye. So we need a screen, which is the retina. Okay, that goes to the optic with the optic nerve to the brain. We're not too worried about that. Okay. Then here we have a lens. Okay, and we have a way of changing the shape of the lens. So we have our lens, and we have the ciliary body, or sometimes called the ciliary muscle. We call it ciliary muscle. Okay. Now, let's get clear about this. This lens is useful in that we can change the shape of the lens. If we can change the shape of the lens, we can change its focal length and its power. Okay, so that's all very important. Okay, so this is our fixed lens. It's a fixed lens. It's in the same place, but we can change its power. Okay, and so therefore we can change its focal length. Okay, so we can change the focal length and the power of that lens. Okay, by changing the shape of it using the ciliary muscles. Now, outside of that, and which is very important, we have the cornea, off the diagram, okay, cornea, which is the air to cornea interface, okay, and then we have a liquid in here, okay, these are called the aqueous and the vitreous humor, but we'll just call it a liquid here for the time being, okay, and basically what we actually have here is we have two lenses to form a lens system, and that's the important thing. The first lens, the cornea acts as a lens. And a lot of refraction takes place here. The most refraction takes place here because you're going from air, which has a refractive index of 1, to the cornea, which has a refractive index about that of water, about 1.3. Okay? The liquid in here has a refractive index of about water as well. So you get refraction going from air to cornea, and then from cornea to this lens, much less refraction. So this lens is actually acting, causing much less refraction. So cornea, the air cornea, so effectively if you want to call it the cornea lens, is the most powerful lens. The lens in the eye is a less powerful lens, but we can change its focal length, we can change its power, which is what's very important. And the two of these go together to form a system so that the image is formed in the retina. If the image isn't formed in the retina, you're going to get a blurred image. Blurred image, okay, right, okay, and if it is formed in the retina, you get a sharp image, okay, and that's why people wear glasses, and that's the next step. Okay, look at the proper diagram in your notes and make sure you're comfortable with it, okay, regarding that. But the lens system, let's recap. We have a cornea lens, okay, where most refraction takes place. We have the lens where less refraction takes place, but we can change the focal length, crucial, okay, and we have the retina, okay, where the image is formed on the screen. It's a real image formed on the screen, and that retina sends information. If the retina is formed if the image is formed in front of the retina or behind the retina, at the retina, you're going to get a blurred image, okay, and that's why we have to wear glasses, some of us, okay, because our eyes are just too good. They're too powerful. Our eyes are too powerful, okay. So if we have a look at the defect, okay, so the diagrams are absolutely shocking when we get the idea, okay. Now I'm simplifying it here, causing these two lenses to be one lens system, and I'm kind of putting it at the lens. That's just simplifying. We know in reality a lot of it is happening at the cornea. It doesn't matter. The problem here is the rays coming in parallel, the image being formed in front of the retina. The lens is just too powerful. It's just too good, like my eye. Okay, right. So what you have to do is you have to reduce. You have to think about it. You have to reduce the amount of converging. And if you want to reduce the amount of converging, you put in a diverging lens. Okay. So to correct that, you put in a diverging lens, and the diverging lens will cause the image, I'm not going to go into it, to form at the screen, okay, with the correct diverging lens. Here, it's not converging a lot, so that's called short sight. Okay, look at your notes, short sight, image in front of the retina, eyes too powerful, okay, you put in a diverging lens to reduce the power, to reduce the amount of converging, okay, and you get the image on the retina if you have the correct power diverging lens. This is the long sight, okay, right, that's when you can't see far away properly. Okay, here you can't see up close properly. Long sight, the object is behind the retina. It's not converging enough, so you want to make it more converging. You want to make it more converging, okay? So you have to put in to increase that, you add a converging lens to increase the amount of converging, to increase the power of the lens, and that will bring them in closer together. Okay, again, the diagrams are awful. Okay, it's a better, the clip makes it look clear for you. Okay, so recap. Okay, two eye defects. I hate the word defect, but they call them defects. Okay, if your eye is too powerful, which is what's called short sight, okay, you can't see very well in the distance, the images are being formed in front of the retina, you need to reduce the power of the lens by putting in a diverging lens, a negative power, and therefore it moves the image to retina if you're correct. And the opposite applies for long sight. Okay, that's it. That's what you have to remember. Be able to draw the two simple diagrams, look at the notes. Very good.